We got there, Chris?
This here is some lignin. See, the lignin here is inside the wood and I'm trying to separate it out at 0.0005 purity. Holy cannoli!
Chris, isn't there a better way?
Oh, well I guess so.
So, how do you do it, Chris?
Well, the first thing we're going to need is a batch digester. Here's one I snagged off eBay. Next, we're going to need some wood chips. I've got a whole bundle of pine chips here, so let's screen them using this gyratory screen. We're looking for chips of 19 to 25 millimeters, with no knots and no bark. This should help improve the quality of cooking. Finally, some white liquor. There's about 136 grams per liter of active alkali and 35% sulfur content. Don't ask me where I got this.
Where'd you get it?
Anyways, we'll start cooking the chips in the batch digester, along with white liquor. We'll also have to maintain a 4:1 liquid wood ratio, so we'll throw in some water there as well. It should take only about 100 minutes to get to around 170 degrees Celsius. That's when we'll actually start cooking.
Awesome!
Yup, after all that cooking, we're gonna end up with a nice big jar of black liquor.
Can I drink it?
You can try, but please don't. I need that. Now then, we'll throw in some strong acid. Let's use this 20% sulfuric acid here. We're hoping to precipitate out as much lignin as we can. We can separate out the lignin from solution via filtration. After a few water washes, it's off to dry in the oven. Make sure the temperature isn't over 40 degrees Celsius.
3 days later.
Hey Andrew, wake up!
What?
The lignin is done drying. Let's go take a look. The one on the far left has a pH of 2 to 3, while the one on the far right has a pH of 7.
Cool chocolate!
On phone. For
That's pretty
$50 a month, you get
Yeah.
unlimited nationwide
This guy looks
calling,
pretty familiar
without
now.
a contract or any activation
new
fee
channel?
in your existing phone.
Yeah, sure.
And you're ready to go.
Hello, welcome to Cooking with Joe. Today we're going to make a carbon fiber monofilament using purified lignin. So for today's recipe you need the following items. Some acrylonitrile monomer, some free radical initiator, some hydrogen peroxide, some chloride ions, dimethyl sulfoxide, nitrogen gas, and purified lignin. So to start off, I want to make a polyacrylonitrile polymer. To do this, we're going to take our monomers and add some free radical initiator. Now, the polymerization reaction will happen under 70 degrees Celsius and have a nitrogen gas atmosphere. And we're going to let that sit for about 3 hours. Oh, hey, you guys are back now. Okay, so my solution has been sitting for around 3 hours. I've just put it in a cup here. So the next thing we want to do now is create an initiated lignin solution. To do this, I'm going to add some of my purified lignin to some hydrogen peroxide. I'm going to add some chloride ions. And I'm going to let this react for a while. But to save time, I've prepared a solution ahead of time. Here it is, our initiated lignin. So now, I'm going to add my initiated lignin to my polyacrylonitrile. This is going to undergo another polymerization reaction at 70 degrees Celsius under a nitrogen gas atmosphere. Okay, so this has been cooking for about 6 hours now, and our polymer should be complete. All that's left now is to precipitate it out and purify it. So, to precipitate out the polymer, I'm going to add some acidified water. Alright, you start to see the polymer precipitating out of the solution. You can see it right here. So now to purify it, we need to evaporate all this liquid off and bake the remaining powder. But to save time, I've done this already. So now all that's left is to create a polymer solution. This is done by adding it to some dimethyl sulfoxide again. Now we're off to our polymer extrusion machine. Hello, I'm back from the polymer extrusion machine, and here's our monofilament. Now, at this point, it's not really a carbon fiber monofilament yet. We still have to drive off the volatile compounds. To do this, it's going to undergo carbonization. We're going to use our 1000 degrees Celsius oven to do this. Okay, our carbon fiber monofilament should be done. Let's take a look at it. Ah, very nice. As you can see, it's been reduced down to its carbon fiber backbone. We now have a usable carbon fiber. I hope you enjoyed Cooking with Joe.